Let's, huh?
You just like record the screen.
It records the screen and it's got a mic built in, so it records the. All right, we're going to start with rate of change, which is actually the same thing. Tell me how you find rate of change or slope.
You do the y equals x plus b.
Okay, that's slope-intercept form of a line. You do, when you're talking about points in the Cartesian plane, okay, coordinates, you do the difference in y divided by the difference in x. So we're going to be a little bit more sophisticated in how we write this. We're going to call this delta y over delta x. Have you ever seen that before?
Yeah.
Okay. The delta sign is used in math to indicate change, okay? It just means change. It's shorthand. The further you get in math, the more symbols and things like that we use. You'll get to where you can write a whole mathematical sentence using all these symbols and things. At least I did by the time I got to a certain point in college. It's what we do in math. Okay, so this means, this is delta, that's what we say, and it means change in. Okay, so change in y divided by change in x, and it makes sense if you think about it, because remember, it doesn't matter if you do y2 minus y1 or y1 minus y2, as long as you do the same thing on the bottom, right? All right, so let's think about this. I'm going to read the example number 1 in your book because it's chemistry. This is what my husband does for a living. So, the table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in the temperature for the solution. So let's think about this. I'm going to put the table up here. So the time, I know this is very easy for y'all, but we'll do it anyway. The time versus the temp. So at 0 minutes in, the temp was 1436. This is Celsius. This is minutes. At 2 minutes, 1394. Nope, 5 minutes. That is pretty hot. 1331. At 8 minutes, it is, oh, there's a decimal in there. I couldn't see it. I was like, wow. That's like lava. Okay, 126.8. And then 12 is, God, this print is so little in this book. I definitely couldn't see the decimal there. All right. So a couple questions for this. One, what is the average rate of change of the solution? How do you do that?
The y thing.
So let's do it and let's interpret. Average rate of change. So we said the y thing, the change in y divided by the change in x, right?
Yes.
All right, so if you start with this one up top, you got to start with this one on the bottom. 143.6 minus 139.4 divided by 0 minus 2. Now, before I plug all this in, should my rate of change be positive or negative? Why?
Because it's going down.
The temperature's going down. As the time increases, the temp is going down, right? So I should get, bless you, a negative rate of change. So plug this in and see what happens. What do you get up top? What is it? 4.2. Divided by negative 2 is what? Negative 2.1 what?
Celsius.
Degrees Celsius per minute, right? Degrees. Come on, pen. You can do it. Per minute. So every minute, it's dropping an average of 2.1 degrees, right?
Wait, but how do you know that?
Well, Oh, so that's what I was going to get to next. How do we know that it's constant? How do we know that the rate of change is the same? We have to find the rate of change between all the points and make sure that that rate of change is constant. Does that make sense? Tell me this, and in this case it is. What happens if it is constant? What kind of function am I looking at? Linear. If the rate of change is the same all the time, then it's a linear function. If it's not, I've got something else, right? It could be exponential.
Or it's going to go down.
Quadratic. I see you're doing all the little, but yeah, it could be any of those. But linear keys us in when the rate of change is the same. We know it's linear. Okay? Everybody okay on that? I know this is really easy for y'all, but one more thing. There's really not a lot with this lesson, y'all, I promise. That's all well and good, right, that we have a constant rate of change, but in the real world, most things are not going to be constant all the time, exactly the same. So what we can do is we can find the average rate of change if we take that very lowest point and that very highest point and we do the rate of change there. So let's say we were looking at the fastest growing restaurant chain in the United States during the time period of 2001 to 2006. And so graphed, and I'm not going to give you every specific point, I'm just going to give you the little endpoints. But when it's graphed, it looks something like this. Definitely not linear, right? But we can still use the data and find the average rate of change looking at the lowest up to the highest. So let's say this was 2001 and there were 7 restaurants. And let's say in 2006, there were 34 restaurants. What's the average rate of change? Per year, on average, how many new restaurants popped up? So again, to find that average rate of change, delta y over delta x. What do you get? Figure it out. Tell me what you get. This is entirely too easy for y'all, I feel like. We got it?
Yeah.
5.4?
So about 5.5 restaurants.
That's right. Approximately 5.4 new restaurants each year. Easy? Is that not what you got? Is that not what you got?
I got 5.25. It's just it's not.
Let's see. 34 minus 7 divided by 5. .4 restaurants per year. Does anybody need any extra help with any of that? It's pretty easy. Y'all, I feel like we need to do a little bit of lines.
I feel like we know
Your knowledge just a little bit. Let me ask you some slope related questions. Why does it not matter which points you use for x and y when you're calculating average rate of change or slope? If it's this, if it's linear, why does it not matter?
It's constant.
It's constant. The rate of change is constant. It's going to be the same between any 2 points that you pick. What is the difference between zero slope and no slope? Remember slope, delta y over delta x. How do you get 0?
If it's
if it's horizontal, so if the difference in your y's is 0, so it's a horizontal line, so 0 slope, horizontal line, and then no slope, y.
Oh.
Because it doesn't. A slope of 0 means no. Like,
A slope of 0 is no change, that's a horizontal line, but what about a no slope line? Why does a vertical line have no slope? Think about the slope formula, the delta y over delta x.
Change in x.
There's no change in x. What happens with a fraction when you have a 0 on the bottom?
It's not a whole, it's not even.
It's undefined, right? You can't divide by 0. So it's an undefined slope or no slope. That's why. Vertical. I got y'all on that one a little bit. I think that's about it. Who? Let me just show you this as I look at your homework. If you have the equation of a line, let's say I have something like negative 2y minus 16x equals 41. How would I find the slope of that line? You got to solve it for y so that it looks like this. And this is what? Slope. Right? You solved it for me? Negative 2y equals 16x plus 41. So what's the slope on this one?
Y equals negative 8x.
So what's the slope?
Oh,
Negative 8. Negative 8. You remember now?